So over here, we'll be looking at point number 3 of NMR, the splitting pattern, using what we call the N+1 rule. Okay. Using the same examples, propane and methylbutane, I'll be going through with you how do you find the splitting pattern of each of the peaks that we have seen just now. Back to propane first. Let's do an easy one. There are 2 signals, right? But the thing is, the peak that you see in the NMR spectrum are not just waves or mountains, right? If you look at them clearly, they are just lines, fine lines. Okay? Some of them will have single line, some have 2 lines, 3 lines, 4 lines, or multiple lines. It gets more complex for bigger molecules. But we can determine how many fine lines there are in each of these peaks. Let's start with proton A. Now to do this step, you need to just imagine you are one of these protons, okay, in this environment, let's say A. So suppose I'm this proton here, okay. I have to ask myself, the carbon I'm connected to has how many hydrogen that the next carbon connects to? Basically, okay, I'm here, this is the carbon I'm connected to. The immediate first carbon, which is only this, has got 2 protons. And these 2 protons are different from where I am. So using the rule N+1, this N here becomes 2 because there are 2 different protons 1, 2, 3 bonds away from me. And then add 1 to this, I get 3. This 3 means I have 3 fine lines for my signal in A. And we call this a triplet because the splitting is in 3 lines, a triplet. This is for signal A. Now for signal B, imagine you are here, okay? You ignore this guy here because it's the same environment. Then you ask yourself, 3 bonds away, 1, 2, 3. 1, 2, 3. So I will have 1, 2, 3, 4, 5, 6, 6 neighboring protons that are different from where I am. So using the same method, I write 6 plus 1, I get 7. So that means the peak for B, you see 7 fine lines. 1, 2, 3, 4, 5, 6, 7. Okay, for signal B. 7 in NMR will be called a septet. No, September? Or in other cases, people can call it heptet. All right. Let's look at the other example, methylbutane. Starting with environment A, how many neighboring atoms of hydrogen that are different from itself and 3 bonds away for A? Let's go. The first carbon away from here, this guy has 2 carbons. Pardon, 2 hydrogens. Freudian slip, excuse me. So we use 2 plus 1 equals to 3. So we have a triplet for signal A. For signal B, we start from here, right? We can go both left and right. So if I go to the left, this carbon has only 1 hydrogen. Keep that in mind. If I go to the right side, this guy has 3 others. So in total, we have 4 hydrogens that are different from where I am in the next neighbor. So 4 plus 1 giving you 5. So we see here 5 fine lines for the signal in B. 5 will be called a pentet, like pentagon. For environment C, so I originate from here and I go, okay, wow, here we have many paths, left, right, and up. So let's go. 3, 4, 5, 6, 7, 8. So we have 8 neighboring hydrogen that are different from itself, plus 1, I get 9. So in the spectra, I will see 9 fine lines around it. Okay, 9 will be no net. Okay, no net. That's the trouble when you want to play tennis in a court, there's no net. Okay, that's for signal C. Now, someone may ask, how come I didn't even go there? Remember, this is only 3 bonds away we care. So 1, 2, 3, we reach here. If I want to look at this, it will be 1, 2, 3, 4. In our syllabus, we do not look at what we call the 4J coupling. Okay, we only look at 3 bonds away from the proton. Remember. Now for the last environment, proton D. So like I said, since they're all the same, you can start from any one. Let me just start from here. Okay, let's go. 1, 2, 3. I can only reach this hydrogen. Please don't tell me 1, 2, 3 and do this, alright? Anyway, the bond is too far away, 1, 2, 3, 4, and they are the same environment, so we do not care. So there's only one proton neighboring to the D. So 1 plus 1, I get 2. That makes a doublet for environment D. Right. So if you are asked to predict the NMR spectrum of metylbutane, you can tell me that there are 4 signals. Any signal integration will be 3:2:1:6. And the splitting pattern for each of them will be, there's a triplet, there's a pentet, there's a no-net, and there's a doublet. You can even tell me that specifically to each of these splitting, what is their integration ratio. So for the triplet, it must be a ratio of 3. Because there are 3 of them in the environment. For the pentet, which is the B, I will have integration of 2. For the no-net, integration of 1. And for the doublet, integration of 6. So you can predict the NMR spectrum of molecules that you know the structure. Let's finalize by going back to propane. How would the signal look like? We have a triplet, we have a septet. Integration ratio between the triplet and the septet will be 6:2, which means 3:1.